Hello, everyone. My name is Augustine Kenaje. Today's presentation, we are going to talk about comparative analysis of battery electric vehicles and plug-in hybrid electric vehicles. I'll be doing this presentation with Francis and Fumibi. Now, what are battery electric vehicles? Battery electric vehicles are vehicles that use one or more batteries to store electrical energy that powers the motor. And plug-in hybrid electric vehicles are vehicles that use one or more batteries to power an electric motor. So we want to compare battery electric vehicles to plug-in hybrid electric vehicles and to see which of these are common among consumers. So our data was collected from the Washington State Department of License, and these are registered cars and vehicles that were registered as of September 30th, 2023, and they are currently on record with the Washington State Department of Licensing. So if you buy a car and you want to use it as on the public roads, then you have to register the vehicles with the Department of Licensing. So that is where we collected our data. And this is the link to the data we used for our analysis. So we had a lot of variables for this data. We had county, city, state, model year, make, electric vehicle type. So the county is the geographic region of a state that a vehicle's owner is listed to reside, and the city in which the registered owner resides in. And we have the model year. The model year of a vehicle is determined by decoding the vehicle identification number. And the make of the vehicle is the manufacturer of the vehicle. And we can also determine that one using the vehicle identification number. And the vehicle types are we have the battery electric vehicles and plug-in hybrid electric vehicles. These are the two types of electric vehicles that we have for this data. We also have clean alternative fuel vehicle, and this categorizes a vehicle as clean alternative fuel vehicle based on the fuel requirement and electric only range requirement in House Bill 2042 as passed in 2019. Then we have electric range as another variable, and that describes how far a vehicle can travel purely on its electrical charge. Then we have the base MSRP, that is the lowest manufacturer's suggested retail price. And we have legislative districts. So we have a lot of variables that were in this data, but these were the variables we used for analysis. Now, for this project, we're interested in which of the counties and cities adopted electric vehicles more rapidly, which of the counties and cities vary, how they vary in terms of electric range, and what are the consumer preferences, which model or which make or which vehicle or brand that they prefer, and how do the vehicle types, that is, we have the battery electric vehicle and the plug-in electric vehicle, how they vary by electric range. Now, we said that electric range is how a vehicle travels when it's powered or is charged. So we have that we want to compare electric vehicles by their ranges. And we also wanted to determine the distributions of electric vehicle models. We also wanted to determine the market share of the different vehicle types. We know that the vehicle types, we have the battery electric vehicles and the plug-in hybrid electric vehicles. And we also wanted to determine the distribution of the MSRP within the different vehicle categories. And we're interested in the display of the vehicle prices over the years. So we had the model years, 2010, 2020, like we have all these years. We wanted to determine the prices of the vehicles in these years. So what we did was we read the data file, then we used the structure function to display the structure of the data. Then we use the summary function to summarize each of the variables in the data to get a fair idea of the variables we have. Then we also use the mutat function of the deep layer package to also transform the columns of the data so that we can get them as factors, because since most of the variables were categorical variables. Then we also use the arrange descent functions to also arrange our variables, since we're interested in the top 10 of most of these variables. We filtered our data by the counties and the cities. And we also filtered the original data to obtain the top 10 counties with the highest number of vehicles. So for our data visualization, we use ggplot function of the ggplot package to construct bar plots. Now, the bar plots will give us the distributions of these vehicles. We already talked about the objectives of the presentation, so we used bar plots to get the distributions. We use box plots to also get a fair idea of the ranges, the electric ranges, and to also distinguish between the battery electric vehicles and the plug-in electric vehicles. And we also use line plots to determine the prices of the vehicles across the model years.
Okay, so the first thing we did with the data was to get a fair idea of what the data is really showing us. So what we did was we plotted the average electric range by state. So from the plot, we were able to see that the electric vehicles in New Hemisphere had the highest average electric charge, since vehicles in New Hemisphere traveled the farthest purely on the electric charge, whereas electric vehicles in Kansas traveled the least, as we can see from the plots. We saw this as one of the fun facts, because as we can see from the plots, we have this plot here showing somehow like a unique plot. So this is why we picked this as one of our fun fact plots. And then the next one was the total vehicle by state. And from here we saw a large bar for Washington State, indicating that most of the data sets were from cars registered in Washington. So we have other cars in the data set too, but because most of the data sets, about 99% of the data set came from Washington, we were unable to really show the other states. Then what we did was, for us to be able to see the differences in the other states, we created an outshining, and I will be presenting that now. So here is the outshining that we did. So for the outshining, we have the state, we have the country, you can select the electric vehicle type that you want. So for the plot, you can view the electric vehicle model here. So as you click on the state or county that you want, you can view different plots based on plot 1, plot 2. Plot 2 will also show some plots. Plot 3 will also show, and then plot 4. So for let me try and show some of the things we have here. So you can decide to pick a state. Let's assume you pick Washington, and then you pick let's say Colombia. So here you have the electric vehicle model here for vehicles that were registered in Columbia County. So it was saying most of the vehicles were registered in 2017. And then you can go to the next plot to see the electric vehicle make that were registered in 2017. So from here we saw that Tesla had the highest registered vehicle, followed by Chevrolet. Then we had the make. So we saw most of the make were Tesla and Chevrolet. And then for the plot 4, we have the clean alternative fuel vehicle eligibility. So we saw all of the vehicles were all of the vehicles were battery electric vehicle, BEV. And then we can decide to, okay, all of the vehicles here were battery electric vehicle. But let's assume we pick another state that has plug-in. So you can decide to view for plug-in vehicles alone. And then this would remove plug-in vehicle and would remove battery electric vehicle and only show for plug-in hybrid electric vehicles. So then back to the presentation. So other vehicles were registered, but they were used in other states as shown in the outlining. So as a result of that, since 99% of the vehicles came from Washington, we'll focus on the vehicles used in Washington state alone. So from the vehicles registered in Washington state, we did a subset of the counties, since we had a lot of counties in Washington. So we picked the top 10 counties in Washington, and we checked for the total vehicles registered there. So from there, we observed that King County recorded the highest number of electric vehicles, while Ireland has the least number of, as we can see has the least number of electric vehicles, as we can see from the plot. Also, for the total electric vehicles of the top 10 cities, we saw that Seattle recorded the highest number of electric vehicles, while Tacoma has the least numbers of electric vehicles. Others have a fairly close number of total vehicles in the cities. Then we got a bar plot showing the average electric range of the top 10 counties. So as we observed, Kings County recorded the highest average electric range, as we can see from here. And then Ireland also showed a lower total vehicle, because as you can see from this plot, we have ranges, we have the Legion to range from 10,000 to 40,000, and this yellow is showing the values for this guy here. So King had the highest average electric range here. So we also got the average electric range of the top 10 cities. So as we can see here, for the average electric range, Tamamish had the highest average electric range, but Seattle has the highest total vehicles. So that is what we are able to get from here. And then for the top 10 electric vehicle make, we saw Tesla model. Most people preferred Tesla compared to other brands. It was very popular among the customers, while Volvo has the least numbers of vehicle registered in Washington. Then the next plot was showing a box plot showing the distribution of battery electric vehicle and plug-in electric vehicle. From this plot, we're able to see that battery electric vehicle has a higher electric range compared to plug-in electric vehicle. So this is saying when you get a battery electric vehicle, then you know you are signed up to get a higher electric range compared to plug-in hybrid electric vehicle. Then for the electric vehicle type of the top 10 make. Now we had, this is a stack bar plot where we have the make on the x-axis and the count of the electric vehicle type on the y-axis. So for this, we saw that Tesla only has battery electric vehicle. Tesla and Nissan only produces battery electric vehicle, while Toyota, Volvo, and Chrysler produced plug-in hybrid electric vehicle only. BMW, Chevrolet, and Kia produce both battery electric vehicle and plug-in electric vehicle. So that is what we got from that. Then we made a box plot of electric range by electric vehicle type, faceted by make. So from here, we saw that for battery electric vehicle, BMW has a higher electric range for battery electric vehicle compared to plug-in hybrid electric vehicle. And then for Chevrolet, we saw that it also has a higher electric range for battery electric vehicle to plug-in hybrid electric vehicle. Nissan, Tesla, Volvo has only a particular electric vehicle. They don't have, like for Tesla, they had battery electric vehicle alone. They produce battery electric vehicle alone. So we only have one bar there, same for Jeep and Chrysler. But for Kia, we also saw that Kia has a higher electric range for the battery electric vehicle. So as observed from most of the plot here, it shows that battery electric vehicle have a higher electric range compared to plug-in electric vehicles.
Okay, so in going through with the results that we had, this is a bar chart that shows the KFF eligibility of the mix of the cars. All right, excuse me, this is a box plot. All right, so yes, this is about a plot. And as we can see, the major highlights of this chart is that for mix such as Chevrolet and Kia, Tesla, Nissan, and Chrysler, we can see that they only produced cars that are KFF eligible as compared to a car such as Jeep, which only produces cars that are not KFF eligible. We can also see cars such as BMW that produces a lot of cars that are KFF eligible as compared to the quantity they produce that are not KFF eligible. And the same can also be said for Kia. On the other hand, for cars such as Toyota and Volvo, we can see that they produce more of the cars that are not KFF eligible. Okay, so in going through, we can see that this is a series of bar charts that shows the model year by make. So we can see that for BMW car, we can see that most of the productions or most of the make of the cars were produced from the year 2015 all the way up to 2023. And then for the car such for the Chevrolet, we can see that most of them were produced around the year 2015, and the least of them was produced around just about the same year. And then for cars such as Chrysler, we can see that a majority of them were manufactured around just about this year, and then a few of them were made around the year 2017. On the other hand, looking at the distribution for Ford, we can see that most of them were produced around the year 2015 as compared to the more recent years, which saw a smaller quantity of cars produced. Looking at Jeep, we can see that quite a few number of cars were produced recently, and it was also the same as before. However, for the year 2023, it had the highest number of car production. And looking at the in all, we can observe that most of the make of the vehicles had their model year from the year 2010 all the way to the year 2020. And we can also observe that the distributions are skewed to the left, right? So, and we can also observe that for Toyota, Ford, and Chevrolet, they are the outliers in this chart. So the next chart that I want us to look at is the chart that shows information about the market share of electric vehicle types. Now, we can see that a majority of the cars that were on the market was battery electric vehicles, and they are constituted to nearly 60% as compared to the cars that are plug-in hybrid electric vehicles that made up just a little over 40%. So we can see that on the market, cars that are battery electric are dominating on the market. And the next chart that I want us to look at is the chart that shows the prices of the electric vehicles that are of the top 10 make. So looking at this chart, we can see that the most expensive vehicle is the Volvo, and it has a price that is well over 6,000 US dollars. And right after that is the Kia, that has a value that is just a little over 5,000. And after that, we also have the BM, which is exactly 4,000 in price. And then the next one is like Tesla, which has a little over 4,000 as well. And we can see that the most expensive vehicles are the Volvo, the Tesla, the Kia, and the BMW. And then now looking at the electric vehicle price over model years. Well, this shows the prices of vehicles over the years that they were made. Okay, so we can see that from the year 2002 to the year 2010, the prices of vehicles that were made in that year were really expensive as compared to the prices of those that were made in the years before and the years after. Okay, so this is the information this chart is revealing to us. So in conclusion, we can see that battery electric vehicles have a higher electric range than plug-in hybrid electric vehicles. And also they have a higher market share than the PHEVs. And another another major finding that we found was that most consumers preferred Tesla, indicating that it is the most famous brand among customers. So cars such as the Tesla and Nissan have only BEVs, while cars such as Volvo, Toyota, Jeep, Chrysler, and the likes have only PHEV vehicles. Thank you.